Welcome back to this lecture series. And in this specific lecture, we are going to talk about the steps in the process of translation, where we are going to be moving from nucleic acid language as found in messenger RNA to the protein language as found in amino acids. And there are 3 steps, and the names of the steps should sound familiar. The first step is known as initiation. In initiation, messenger RNA is going to attach to the small subunit of a ribosome. Now, the small subunit is floating in the cytosol when messenger RNA attaches to it at the 5' end, and the messenger RNA is going to move down the subunit until the AUG codon is in the small subunit, at which point a transfer RNA carrying methionine is going to bind. So the AUG with the A on the 5' side of the messenger RNA is going to be binding with the anticodon UAC on the transfer RNA. After the transfer RNA binds to the AUG of the messenger RNA, that is when the large subunit of the ribosome will attach. And what's interestingly is the way the large subunit attaches is that it puts this very first transfer RNA in the P site of the large subunit. It's not in the A site. The start codon is the only one that brings an amino acid to the P site instead of the A site. But now we are ready to start adding amino acid, but we're done with initiation, so we are done with step 1. We're ready to move to step 2, which is known as elongation. Did you notice the steps of translation have the same names as the steps of transcription? That's right. So in elongation, we now have the complete setup with messenger RNA, a complete ribosome, and we have a transfer RNA with an attached amino acid, a protein chain sitting there in the P site. So a new transfer RNA with its anticodon that matches the codon in the A site is going to enter the A site, and the anticodon is going to bind to the codon of the messenger RNA. So remember, the amino acid this transfer RNA is bringing is the amino acid that was coded for by what? By the codon found in the A site, not by the anticodon of the transfer RNA, but by the codon in the messenger RNA. Okay. Once this transfer RNA is in the A site, then the amino acid or the protein chain found in the P site will detach from that transfer RNA and bind to the new amino acid. Now, this is going to take some ATP. Yes, energy is going to be used. And then you have a naked transfer RNA, which is going, this whole thing's going to shift over. So that this P site transfer RNA moves to the E site and will exit. And now this A site transfer RNA with the long peptide chain moves to the P site. Okay, so you see how this has happened here? And so now the A site is empty. The E site gets emptied as soon as the naked transfer RNA exits that. And so we are back to our starting point, the only difference being we have a longer peptide chain. And so now a new transfer RNA can join the A site whose and its anticodon will match the new codon in the A side, and it will bring a new amino acid. And this process will continue repeatedly until a stop codon appears in the A site. When a stop codon appears in the A site, that brings us to step number 3. Do you remember what step 3 was called? That's right, it's called termination. So when a stop codon is reached, and do you remember how many possible stop codons there were? Yeah, there were 3 of them. When a stop codon is reached, no new transfer RNA attaches. In fact, there's a release factor that will attach. And what happens now is the amino acid chain is released from the transfer RNA. Yes, this takes energy. And so now we have a free polypeptide floating in the cytosol. And the transfer RNA moves to the E side and exits. And the ribosome then splits back up into its small unit and to its large unit. And when it does that, the messenger RNA is also released. So what happens to that polypeptide, to that protein with its primary structure? Well, if this was an unattached ribosome, then this can be taken to the Golgi apparatus where it can be processed. You know, we can get a secondary, a tertiary, a quaternary structure out of it. Or it could be, or if this ribosome had been attached to the rough ER, then it can be dumped into the rough ER and it can be separated out in a little vesicle and be taken to the Golgi anyway. So take a moment. I've given you some pictures you haven't seen, but if you understand this process, you should be able to talk yourself through it. Don't forget to mention all the terms that I have listed here. And with this, take a moment, pull it all together. Everything we have gone over in great detail together is a lot more than you see on this one little screen. And by now, you know a lot about DNA, RNA, and protein. And study it, teach it to somebody else. Because when we come back, we're going to put it to use when we learn about our next topics. And we're going to be using this in lots of different topics throughout this course. And thank you again so much for all your hard work.